here is the code for the synchronous run. And there is a package here. So this is a database system for the chips that are refined. So if you want to add your own, also you don't need to add, you can directly write this on the, without accessing this. But you can see that you have the family, the organization, address, bank address, row, data, column, data.
Oh, wonderful. It has all the support in one place.
Yep. So each and here is when you can see that this can be done in VHDL. Why? You can see that DD is the single data rate and the double data rate. Those are the first one is the single data rate that is in the ULX3. The second one I think is the IC version. I don't remember well. I think it's the IC version. No, this is a micron. This is a DDR1. This is, I think, is the one that is in the ULX3 that Mark sent me. And as you can see, in those, I don't know if you can see there, but in those two there is no TXPR parameter. So if I want to do this with a structure, with VHDL structure, I have to add this parameter for the single data rate too. That can be confusing. Also, I have to fill the parameter. So the JSON is really good. It solved me a problem here that is hard to do. There is other things that is described in the family. So all these parameters are for this. That is, I have many chips or single data rate, but these parameters are in all those single data rate. And you can see that I have is again, if I had to do this with a VHDL structure, it's really a mess because I don't know. I think it's this type of database has a name, but I don't remember which is. When you, I don't know, you have heard about LDAP. That is for looking for a user value. Yes, LDAP. Well, LDAP is this kind of database. This kind of database are not relation database and are complicated. So this system helped me to describe this. So this is easier to read. If you want to change something, you can go here, look for the register or whatever. But also, you don't have to touch this. So if you want to add a DDR3, you only have to tell it the family is DDR3.
One small question. For the SDRAM, there exist 16-bit but also 32-bit chips. Do we actually, at this level, have to specify number of the bits, or number of the bits is separate from that?
In the core, if you describe this, you have all the data here. Data. And this is
okay. Yeah. Data. Yes. This is it. Yeah, I found it. Okay.
And this is for the file that we are talking about. And you have Orange Crush here and JX for here. And you can see I don't know which has the latency. I don't remember if it's you or the other one. Anyway, it doesn't-
ULX was ULX was faster. than
which one?
ULX.
ULX4? Yes, I say that was faster, but when I read here, I think I added latency. QSL is latency plus 2. So I think that the ULX has a
Yeah, and it
higher
is maybe
latency.
because of the switch pins. That could make sense, because the original would go faster.
So this is the package for, I don't know how much our length is, with all the utility functions. So what is the functions that are here have to do with the core. Now I will show you the legacy functions, the package. This is a DDR, it's called DDR. And first of all, there are two packages. This is one package, and this is another package. So there are two. And this is a database. So I have to define all the difference with numbers, all the parameters for all the chips.
Yeah, that's the standard way.
Yeah. And the complicate. And then this is the database. So I have to do. Try to feel this.
Yeah, too much of this parameters. It's not visible. It's
not readable.
You just can get lost.
So for me, this is why I decided to do a standalone package of this JSON package, because I think if somebody is coding and I understand this problem, I think it could be very useful, and you don't need to copy the whole system, the whole library. That is, if you are using a code, yes, you are forced to do this. But this could be very useful because it works in all those synthesis tools, and is very readable. On ScopeIO, in fact, is a waveform. This call was I would say in the first release. That is, it is a legacy. But should be called waveform. At that moment, all what I was doing with ScopeIO, even I always was planning to add the capture system to the DRAM, was based on having a video and then sending that to the DRAM. So this is why it was called the video. It was something that was mandatory at the time. Now it's something that could be that if you want, you can choose to have it, or if you want to capture data. This is why before the trigger was in the video system. Now the trigger is off the video system, and I will try to show the different part, but this is a video synchronization that generates.
So I was curious since the last time I saw this external video. Is it appropriate to talk a little bit now about it, or am I ruining your concept? Where does this external video sync is coming from, and what's the application for that, and how does
This is something that
is this overlay, video overlay?
yes, it is something that I think we were working one weekend or something like this, because Goran wanted to use in the what was the
STM32.
it is 32 that I think he showed you showed the other day, an overlapping of the interface with the signal inside that was plotting fast. Well, this is the signal was plotting by this, and all the interface were using the microchip. So in that way was the control what is seen there by using the COs, serial output, and they can plot the signal. So for that to happen, they need to generate the video synchronization. So if you got this, instead of using the video clock, well, you will use the video clock, but the horizontal synchronization, blank, and vertical synchronization will be used inside to trigger the counters.
Okay, so the actual video, so obviously the clock from the video source and the local clock
It's the same.
can never be the same, but will it be good enough? So
No. This is the general. So this is maybe I don't know who is generating. I don't remember who is generating. The video clock is always external. If you see a ScopeIO, the video clock is an input.
Okay.
So I don't know
I also don't know if clock was. We are using, maybe the STM is using the same clock as the.
Yes.
I'm not sure.
No. We were using the same clock.
Yeah.
That's for sure.
Okay.
We were using the same clock.
Yeah.
Yes. And what the other system was sending was the video sync, the vertical sync, vertical one. That's for sure.
Okay, but
because it cannot be.
Maybe I'm getting you wrong. So this external video is actually generated inside the FPGA? Or
No. This
outside.
is STM32 generating picture. So it is just
How is it generating picture?
RGB signal. Like it has RGB output, and we are.
Oh, really?
Yeah.
You can do that.
Yeah. You can use like STM32 on like display. So we usually present that on the display, but this time we took that lines and took it into FPGA, give it to Miguel inside of the FPGA, and FPGA is showing overlay, STM overlaid on the ScopeIO picture. That's the idea. Because it is easy to generate like GUI for STM, you can do some nice things, stuff, and for STM it's hard to show like fast signal.
And where does this go then? To the HDMI?
Yes, exactly. It is shown, both pictures are overlaid and shown.
Okay, that's distraction, but it's new for it. So STM32 can generate a video signal that can be fed to HDMI.
No. It's fed to external signal to FPGA, and the FPGA is combining two actually video signals and showing it on one screen.
Okay.
That's how it works.
So then we have the counters, the synchronization signals. When this is, I need this to count where I am, and I need to count this to where I have to start everything again. The latency, that is the latency that I have to add, because those signals is triggering the counter, the comparison, the plotting. So I have to delay this for them to this is the FPGA, this will be the video. So those signals are going output to the video directly. And these things are using to control the layout. So here I receive the waveform. So as I have the JSON system, I only got the string for the waveform. So this is in fact pretty important, because if I send the whole layout, all the functions that are looking for the fields inside the JSON will take more time, because they have to first locate the waveform and then what is inside. So it's like got first the waveform string and then pass it should be faster. This is something that if you try in GHDL, you won't feel the difference. But for the synthesis tools, I don't know what it's doing inside, but there is a difference in time, and it's your time. So what layout is taking all that number that is in the JSON and then generated when you have to write the readings. The readings are this. No, the readings are this. Those, I don't know if this the best name, but segments will refer to this part of the signal. How many segments, which segment it is. And all these are outputs that telling when that is. If I had to display the grid, this will be on. This is how to display the horizontal range. Let me see. To display this part, the numbers in the horizontal will be horizontal on. This I have to display the vertical will be vertical on. So this is what is doing all the stuff. This is why it's called the layout system. It's telling you what has to be drawn.
And that's actually based on the lines.
That's actually based on the line.
Yeah.
On the line and on the column.
Yeah.
See, so yes, it's. Let's see something here.
Yeah, you frame it at some point.
Okay. This is what I think everybody knows how a processor works. So, remember the register file? Well, remember all the register that I was talking to? Well, you have a copy of everything that is the state of the ScopeIO here. So all the registers are here, all the data that is needed for the register. This is why it calls ScopeIO state. This is state machine, I want to know what it does. Okay. So every time something is changed there, it has to be updated. So what I need to know is what is updated. If I change, someone changes the scale, or someone changes the horizontal. So when that change comes, I am triggering the state machine and telling the corresponding core that it has to update the value. So nothing is happening. I am in user state. If there is a setup request, I am triggering the vertical setup, and then I wait for vertical setup request ready is in 0. So it's all those state machines work as if they were a client server. So if both are the same value, this is why it's doing an XOR, the server is ready and eager. So here what I am doing is, okay, I need the vertical to be redrawn, the vertical axis. So I trigger, and I go to the vertical setup, and I wait for the vertical setup to finish. When that's finished, depending on which channel was, I don't know why I'm doing this. Is I finish with all the, because it's what it's doing this is initializing the whole reading. What I go, if it's not, I continue with the next channel. So this is why here is the channel ID is still greater than 0. I go, it's better go below, and again I trigger a vertical setup, and I keep in that state till finally I get the end. This is like it works as it were a counter. It works as it were a for e equal for e equal, I don't know, 4 to 0, and when I get 0, what I do is initializing the triggers. So I ask for the trigger setup, I change to trigger state, waiting for it to end. Once the trigger setup is ready, that is finishing all the printing, I go for the horizontal setup. And finally, when the horizontal setup is ready, I go to you. So this is the state machine, how I solve the problem without CPU. And also, if you can see, that state machine has 1, 2, 3, 4 states. So it's very simple to do. So you have a controller that is maybe 2 flip-flops, no more than that. And you don't have a big state machine, because what it only does is triggering another that maybe is also 2, 3, 4. It's very simple for the synthesis tool to do it, and it will be fast. Forget about this. This is to cheat the model sim, because the model sim got all the processing only one and makes all these variables invisible. So I added this only to cheat model sim. And this is again 3. You can see has 3 states, and it's the same. If there is, for example, an update in the vertical scale, it takes, that would be the parameters, like calling a signal. It copies the, where I go, where I went. I hope, no. Because it's sometimes it's hard to follow, and doing this is it lost you. So here is somebody touched the vertical scale. So it check who was the channel, which is the channel, sorry, and then calls a request to the vertical to draw all that is needed. Check what is the offset of the channel, of the line that it has to draw. And finally, it does all the reading update. And the scale, in this moment, the triggers, as the scale is, sorry, I didn't say that. The scale was changed, because I know it's probably was changed, I had to update the position of the trigger. So I had to call also update the trigger too. This is why I wait for the vertical to finish. I request again the trigger. And when the trigger is done, everything is finished, I start to immediately again. So this is why what I was telling the other day about how I manage the system with the request and ready. So when I want to call would be the server, what I do is taking the ready value, I negate this ready value and I assign to the vertical request. In the server side, it will trigger what it has to do. That really helped me in a lot of places. So you will see that it's kind of philosophy, I don't know how to say, that I use in the whole system. Well, this is the server, would be the server for the trigger. See that the trigger is 0. That is, if I finish, I am not going to retrigger if I don't finish. If I finish, that is, the trigger is finished, then I check is somebody asking me for update the trigger. If somebody asking for update the trigger, well, first I go to the analog reader, then go to analog reading, then to the digital system. I don't remember what this is. What this state does, I don't remember. But as you can see, the state machine is simpler, and what I'm doing is dividing the task in those state machines. So I can focus, instead of having a huge state machine and having all the things in mind, is I can more or less think in the same way that is programming in C. But there is some advantage of this, that is I need to trigger several systems that I can run with. If it is software with say running parallel, I can trigger all of them and then wait for them to finish. Switch it again. This is the text box. This is not finished. So, if, for example, if you set the text box equals 0, what it will do is deleting this part. All this column won't be drawn. This is for custom application. So, for example, I never remember the EEC.
Power supply board.
The power supply board. So you can, if you don't want this, you don't want to display this, okay, you delete it. You don't need it. So all the waveform can be customized. You don't want this, can be deleted. You want this in internal, it can be added. So the way to disable the text box is setting this in 0. Probably also it's not defined, words too. Those are the segments. You want the segments to be drawn because it's where the signals are. This is again the latency to synchronize all the graphics. So
What will happen if the latency is, for example, off by 1? What we'll see, we will still see some picture a little bit ugly, some pixel off and something.
Yes, for example, if you delay around the which is of this, I think it's a segment. You will see that the first segment of the signal is off. You will see something this shouldn't be there.
Okay. Okay.
But everything is fine.
It could still be usable approximately.
Yes. And you see that the system has colors, and those colors can be changed online. That is, but it's not in the interface with the buttons. But if you plug the PC to the controller of the ULX3 with a JavaScript application, you can change the colors if you want of a segment. That is. Sometimes you want to, especially if you have several signals, like here you have 8, you won't have some different colors to identify better the signal. And then that's it. It's the color pixel, the video blank. This is the delay signal that we have at the beginning. I call it video input output. This is the ScopeIO the video. That is the part of the module that does all the drawing. I don't know if you have some particular thing that you want that I explain, because we have this is the amplifier. I don't think the amplifier has something special.
Trigger maybe.
The trigger is very simple. I will show you. This is the trigger. So you have the data, here you have the level, the scope. Again, this you can replace it. And we have a data value.
Does this trigger work with some kind of let's say sine alike signal, but with a few harmonics and something? Will it stabilize the waveform?
No, here this is the simple one. That is, if something is greater than and it is the slope is the right one, it will trigger. It doesn't do anything special. So it's more like a chord to replace with what you want.
Okay, I have written something. We have to backport it from the legacy here.
Okay. So this is, for example, here there is a delay because I'm not doing the whole comparison. What I do the comparison, I say in quotes, in parts. Because doing these comparisons are expensive. This is abstraction, so it's better to keep in a flip-flop. And then when I have all those flip-flops ready, I trigger according to this, to what is in this line that I don't remember what it does at this moment. But the functionality is the same as standard oscilloscope. So this trigger can be customized as if you want. You can do a correlation between the signals. If you have, for example, you have a self-correlation. What you wanted to trigger here, I'll say, whatever you want to be triggered, you code it here. Well, I think this will be a little bit interesting. I hope you can follow it. It's not. Because what this does is taking a binary number and convert it into decimal. You will see the same philosophy. As I have a trigger, that I have a kind of client server, I have an event, I prepare the data, and I request somebody else to process that data. So again, text request and text ready is where I am drawing the readings, so I won't do anything till this finish. Then, if the vertical ready if it was to change in the vertical system, I will get the scale. I will get the format. So, what is the unit? Is millisecond, microseconds, or microvolt. So I need. This is what this does. This is the decimal point. This is how much should I have to move, how zeros should I have to add or delete. The width is like you have I think you know the printf of C, and you know that there is everybody wants to do this in VHDL. Something like this. Well, you set here this width. This is the scale. This is the scale is the level, micron, and this is the input that has to be updated. That's where the field is. And this is the widget ID. Why I need this widget ID? Because there is the name of the channel. So, want to show we'll try to show this. Maybe you didn't pay attention because it's too much sometimes to keep in mind. It's better to go back and show that.
Just remember I've seen the Ethernet, so just remember to have the Ethernet described next.
Okay.
As a wish.
Okay, we will finish with this and we'll describe the Ethernet. So, those names, you set the names of the channel here. So, I recollect all those names, I set that in a RAM. Also the system that is there in the reading, format them. If you have something that is wider, we get the widest, and we'll align all the names. for it to work. But all this is doing in real. So I will go now to the Ethernet system. I hope I remember how it works.
Really just how you compose a packet and send it out. So the complex part, DHCP, and we can leave that for later. But the basic stuff, how you compose the packet, how you send it out.
Yes.
How you receive it.
Let me find
There
the. This is
CRC ejection. That's
Well,
usually an obstacle for venue.
Yes, I try the CRC. Okay, don't worry. That's all. Okay. Sure that's all, and the Harris, the system. So this is the Ethernet receiver. Maybe it's that's what you want. This is the raw Ethernet. So the data that come from the feed come from there. And this core started telling you when all the fields appear. So the data link layer will trigger the frame and will tell you with the E-read initiator ready when you have to fetch the data. So this is
What is the shorthand of T ready?
target ready.
Target ready.
We are online?
I don't know.
Yes. Yes, no, because it's, I don't want that on record. So, so this system will tell you which is the destination address, and this will tell you which is the source address.
You mean
Of-
like a MAC address or?
MAC address, because it's just only the Ethernet part. So what I am doing here is separating all the fields so you can analyze what is happening. And for example, I need the type because for the RT protocol, the type is different. This is why I'm analyzing the type. And also the system will tell you when you have to check the CRC and if the CRC is valid. So you want to see this first? Because this is nested, that is. This core analyze the Ethernet and tell where are the fields. The next core analyze the IP. The next course analyze the UDP that is sending both. So they are catenated. Also, there is no buffers. So it's like, I found this and I send this. Maybe there are small little FIFOs, but there is no, the idea is that you don't want latency there. You want to answer as fast as you can.
And just to mention, you Marko, this core also has DHCP request.
Yeah. And the response also
In
is fast.
response.
Yeah, I also added the ping the last time because
And the ping.
because sometimes you ask for a request. In that moment, there is a bug in the CRC, not in the CRC, in the checksum of the UDP system. Somewhere, Goran was telling me I'm not receiving the DHCP. I don't receive the DHCP. And then I tried, and yes, there is a checksum program. This is checksum bug because before it wasn't there. I had to see what is happening, and this is why it's rejecting the DHCP server is rejecting the request, but everything else is working with the checksum failing in the UDP. Not in the pin. In the pin works well. Don't assume. Well, so I have to check that. So, do you want to see this or go to?
Yeah, you can start with the
Okay.
MII.
I will show you this to see how you can see the philosophy there. So the first thing is checking the prefix, the FFFF, AAAA, AD. Or this is the prefix. If the prefix is right, so I set it for valid. This is to improve the speed. What it does is, if I have a serial input, it will pack in 8 bits, so it's easier for the system to process, nothing else. So if the preamble is valid, what I going to have is the data link layer well. And then I start processing with the data link layer. So let's go there. But it's also telling me everything else. What I do is I have a counter. The counter is checking when I have to decode the field. The value of the counter is inside the package. This is not. This one. So what it does is all of them are mostly the same. It tells how many bytes, how many octets are for the hardware address, the destination, then the source, and the type. So it basically is a counter that is telling you when the field is valid. The CRC is a general CRC. That is, it's not for the only for the Ethernet. You can use this CRC to check Ethernet or to check HDLC, or you create your own CRC. And what it does is, when it's time for the checksum to finish, it checks, it's enabled, but it is a strobe. This code is old, so maybe this doesn't have the same. Maybe what I'm going to tell is the names are not good. And here has the checksum. If the reminder is the one that is on the standard, it will be valid. If not, it will be invalid. And this is the moment when you have to check that. So if you want to check.
So how do you know when is the moment to check this? The packet flows. It has a preamble, it has a source, destination, source, MAC address, I never remember which one.
That doesn't matter.
And then just the data flows. And then the CRC should be basically the last pair of bytes, or
There are
is it
4 bytes.
more? 4 bytes.
Yeah.
And then, well, how do you know this is the last 4 bytes have arrived, and there's
Well,
no.
the frame ends. So the feed tells when all the data is valid, and when it goes 0, that was the last.
Okay,
Data.
then you have to delay something a little bit, because you can know that the frame is done only after it has eaten
Yes.
the CRC.
Yes. So the CRC comes in the package. So the last. This is the last data that they're gonna have when the package ends, and a cycle later, I have everything done. Because the CRC is calculating it for each byte that is receiving. It's not that I have the whole package. I am analyzing every time there is a byte that comes.
But you have to stop. You have to stop at the CRC and not throw in the CRC the byte that.
You
Yeah,
want to avoid the last 4 byte?
Yeah, yeah.
No, I isn't. Because remember the registers I have? So with registers, and there is a trick. Each register has what I was doing. Anyway, this is go up, but when I send the register ID, I send
The link.
the link, and I say the length, yes, and then I say the data. So this sends everything, but I think is in the CO system that receives this, there is also you're going in something that you don't want to go, and I don't want to go either. Yes, that's come. I will show you what without changing.
I don't want to ask questions that have obvious answers. I have no idea.
No,
how
it's
this
perfect. Perfect. And I don't want to go there. This is CO system. So the CO system is the one that it doesn't know anything about the link system, but it knows everything about how the data is formatted. So let me see the UDP system. So this is. So you can see this system receive directly from the file and transmit directly to the file. This is the code that we were seeing before, where it is the ETH RX. So this the MIOP send the data to the CO flow. The CO flow collects all the data that comes from the MTH, and that is the one that deletes the last 4 bytes.
Okay.
So I think that is your question. Who is deleting the last bytes? Let me see something else, because the UDP package, what I'm doing is receiving the UDP package, and I don't remember now the IT package is the one that.
Here is the payload frame.
This is the receiver. This is the payload.
Makes it easier for everyone. If we get lost in other people's VHDL and feel bad, when you get lost in your own VHDL, then
No, yes, was a long time ago. The problem is I don't remember if I leave the CRC in the packet. There was a moment I was doing this because what I was doing is sending some null register at the end, so the CO system will discard that because nobody was using it as a simple way. Because it's not, I had to count the last 4 bytes and discard it. So
But when you send it, then you must have a CRC.
yes, when you send you have to.
You can ignore it when you're receiving.
Yes, but the idea is that it takes some hardware and I didn't want that because it's not I have to delay the data for, I don't know, that's what I am doing, don't remember that way. You have delayed 4 bytes, probably is what I was doing, but I cannot find. And then I check the CRC and the last 4 bytes of the valid packet is just at the same time that I am detecting the CRC. So probably it's that, but I couldn't find it.
What is happening, for example, if you receive packet with wrong CRC? Because if there is a logic that you process everything as it comes, so there in the end there has to be some kind of a rollback discard logic.
Yes.
Whatever you calculated so far, it is not valid because CRC is not valid.
Let me show that.
Which is a good point, that we normal mortars will just buffer the internet.
We will just buffer, yeah. we will buffer all not here.
Yeah, that's a good point. That's I have to dig into hacking internet into FPGAs.
Something like this. Rollback, commit.
Oh,
Something like this. Okay. That's the FIFO that does almost everything for me. It's an asynchronous system. It can be synchronous or synchronous. If you use as synchronous mode, it will be faster and with less resources. But I had that trouble. So I said, if you want to use it as a user, standard user, everything is with default values. On rollback is always zero, and commit is always 1. So you don't need to do anything, and you have an overflow signal that if you don't care, let it pass. So with this FIFO, I control this when there is a failure in the CRC and discard the package.
Yeah. So in the FPGA, you have, of course, plenty of the registers units, and they are used to roll back. So they are first loaded to some registers, probably, and there will be just not final write.
No, this is a block RAM. It depends on what you want. It could be a block RAM or could be a distributed RAM. What I do is simply updating the pointers. So is I am rolling back?
You just reset the pointer.
Exactly.
Yeah, nice.
That's solved.
So nothing good.
The problem. No, this part wasn't difficult. The more difficult part is this. When you have cross-clock domains. I use a lot of time cross-clock domain, and this now is working. I have some. Before I was using cross-clock domain, I didn't have any problem, but this wasn't working. So when finally all the, I had something completely unsynchronized, this system failed, and I found the problem, and I solved it. So if you set here that you want an async mode, you can get cross-clock domains without any problem.
Without, yeah.
So probably maybe I delay this. I don't know where I'm delaying it at. And on the others, I think I'm delaying this 4 bytes because finally to make the commit I have to check if the CRC is valid. And delaying this, you won't pay much price. Also, if this is a shift register, depending on the manufacturer, shift registers are really
cheap.
chip. So and the latency, you're not going to get much latency. So I will try tomorrow to find where I'm doing the delay.
Is the IP and UDP checksum also
Yeah?
done project on the receiving side?
The UDP or IP?
Both are they both done? Both checksums, yeah.
Yes.
And how are you fitting the virtual header for the UDP checksum? You just
The header for the sorry.
for the UDP checksum, there is a virtual IP header before it.
I don't remember if I do the. I don't remember if I do the UDP checksum. You know that in the new in the IPv6 you don't have that checksum anymore
Yes,
because
but UDP still has the checksum that includes the source and destination of the IP header.
yes, I know. Yeah, that's what it's about. But I do it online. I will show you. Do you want if I check that or when I do that? There are two-
How you check it? Do you just feed like the CRC
I don't think
before?
I check that. I think because you have the CRC. So the CRC valid, the checksum won't add much.
Yeah.
The problem is when you send that.
Yeah,
That's the problem because
it has to be filled.
Yes, because they are going to reject. You have two different solution for that. One is filling the checksum with 0. You know that is filling with 0, as it is a complement -1. It's the other. I had to do it because the PHPC server doesn't like that you send the signal. So you can see that here is a. But let's see how I do it in. Because the UDP is the same IP address, and what I'm doing is inverted it. So the checksum header will be the same. So I think I got the checksum from the original packet.
I have a question.
Yes.
If I would like to add a new board to do with
Yes.
ScopeIO, what are the steps I would need to do for that? Is
Try
it-
to copy one of the boards that are here. For example,
Both
suppose that you
similar.
have the Silence version. I don't know if that's the one.
yes.
Okay. Mm. Let's see. Silent version. This is the Silence version. You will see that most is the same. Here I'm using more resolution.
Hey, what's the minimum resolution ScopeIO can work, or can you it still work with the small displays?
I have to try. Probably yes, but I don't have the resolution. And if you want to dump those in the memory, so this is ready for you to use. DDR3. And so here you have all what you need to generate the clocks. Also you have the link for the Ethernet. Tomorrow I will check that what you want me, because I was doing it.
And you have a tool chain on your laptop.
Mhm.
Yeah, we can probably try it tomorrow, so we will just copy this and try to.
This is the controller with the buttons. You can delete it, and this part is the ADC that you know all the Arctic 7 has. So this can be deleted and replaced with your code that is generating the data. And here you have the ScopeIO. With the DRAM and the fee.
Okay, so not many changes at all.
No, and if you want, I don't know, you were using the open source.
Well, yeah,
No,
I can use
online.
also Vivado with it.
Ah,
Yeah, no
okay,
problem.
so you have a project.
Mhm.
Okay, now I reduced image to 640
That's okay.
480, and it won't compile because it says number of what kind of segments or something, boxes with some apps cannot be greater than displays with. How can I easily fix this?
This has to do with the.
Oh, number of segments. So I can say just one segment probably.
Yes,
Okay.
that will complain.
Mhm. I'm looking just for some easy solution, just to get it compiling. And
Yes.
I tried out of the box, but somehow monitor doesn't want to display.
This monitor,
Mhm.
yes, doesn't want to display. This because we try and
Mhm.
and it works. So
Yeah.
it flashes from some
Flashes, yeah, and I will change the resolution to some low one, and let's see.
Okay, the system complains when the size of all the margins, the size of the grid
Mhm.
is greater than the width or the height. So then we'll tell you, I cannot put all what you have asked me
Mhm.
in this.
But it takes so much time. I started compiling, and I have to wait a few minutes just to have this problem reported.
There is,
okay.
yes. If you use a simulator, sometimes what I do is
Mhm.
running a simulator. The
Mhm.
simulator will
Mhm.
will tell you that message, because this message is a message that is reporting by ScopeIO. It's not a compiler message, because what it's doing is
Mm.
what it's doing in ScopeIO is you are
Ah.
asking me this size of grid, you're asking me
Mhm.
those margin, and when I added all of them,
Mhm.
I go out of range by
Aha.
width of the height.
Yeah.
So this is something that is an assert statement that is inside
Mhm.
the system to stop and not
Aha.
generate a wrong
Okay.
system,
Okay.
wrong
Okay.
bit cycle.
Okay. Okay.